Hello everyone, welcome to the stream. The stream will begin now. Um, I wasn't able to stream in the couple of weeks, but I still worked a little bit on the game. The current state of the game is not too advanced. I just did some background stuff. One announcement I have is the source code for the game is now online. It's open sourced. You can get the source code either on GitHub, it's just the source code here without the assets, or visit my itch.io, the links are also in the description. So you can get the source code either on itch.io or GitHub. And let's see, the code should compile still since excuse me, since I didn't change much. So the current state is I just worked on GUI stuff in the meantime when I couldn't stream. So the gameplay is looking pretty much the same as before, but the debug windows are new. I can enable and disable debug output. This is just debug stuff here. It doesn't do anything. Just some testing of GUI controls. Let's see, the frame time. Me streaming doesn't seem to affect it too much, although the min FPS is kinda low, but we're still hitting 60 FPS, so that's fine. I changed how I can now switch between the different contexts. So this is the voxel editor, this is the game mode, and this will become the texture atlas editor. Wait, that was a bug there. Interesting. Me opening up the windows here opens up this modal screen without it being modal. Wait, let me try this again. Huh. If I close this, the the output window here closes also, even though they are unrelated. Okay, interesting. What's going on there? Let's see. Where is the texture pack? Right, that's here. So basically, those two screens, the two dialog boxes should be on different instances of the IMGUI structure I'm using, but they seem to be sharing memory. Yeah, this is the modal window, or maybe it's because it's static? No. Alright, let's see. To debug GUI, this is the debug GUI the game uses currently. It's generating its containers using the right... Yeah, this is the right one. So they are using two different states. So this modal screen doesn't go away, but if I hit close, it closes this one too. But it shouldn't be happening because I'm binding the right state, GUI state, and all of these calls after binding should only modify this state. And this code over here is working on a different state, since I'm binding a different instance of the GUI state. Okay, so maybe it's because when I hit tab, oh, that's a problem. I'm getting the container without specifying which before I'm binding the state. So do I have a version of this that takes an explicit state? It does. Alright. So to be 100% correct, I would have to let's do it this way. I shouldn't be calling IMGUI methods before binding, which I currently am doing, but these container manipulation stuff are a little bit special. Let's see. Oh, this one's an ID. Right. Okay, there's still a bug that once I switch into the other view, I can't open up the debug window anymore. Once I switch here and back, yeah, I can't open the debug. Okay, so let's reproduce that. So what happens if I press the tab key? So I get the main dialog. Thinks it's showing, but the dialog is hidden. How does that get hidden? Okay, so let's use I'm just gonna use a what's it called? A memory breakpoint. Oh, damn it! Now it's gone. Let's see. No. Okay. So these flags, I need the memory location of that, which is this value, and then we can create a breakpoint for that memory location, and this breakpoint will hit if any instruction in the program messes with this memory location. So basically I want to know where exactly I am setting the dialog box to hidden. Interestingly enough. Alright, I must have messed up something since we're not triggering the breakpoint. That's weird, why is it not triggering? Oh, so maybe that isn't the problem, that's why it's not triggering. So the flags are staying 0, it seems. Yes. So the dialog is not hidden. I then stop showing the GUI. So that's fine. But if I press tab again, I should be showing it. Now I'm showing it. Wait, why did this trigger? Oh, it's the same bug as before. I'm not getting the right, since these calls are before I'm binding. So I thought I fixed that and I just skipped over one of them. Okay, that is an annoying bug. So to not have that bug creep up in the future, I'm just gonna write second bind that just binds the state without initializing it. So this way, even if I'm not actually doing any GUI code, I can bind the correct state. So I don't, even if I forget to specify the right state when getting the containers, that won't be a problem. Okay, so okay, all three GUI states are not now independent from each other. Okay, good. So for the texture atlasing, that is actually what I wanted to work on today. I did a little bit of pixeling, so I created this sprite sheet that is supposed to be the player. Why is this looking so pixelated? Wait, I don't want it to resample. Why? This program, it's pretty good for displaying a bunch of different extensions or file formats, but the interface is really bad. Right, first of all, background color. Color for cut, no. I meant just, oh, here it is. So now the background is still black. I don't get this program. That's window color. Okay, this is working. And then when zooming, just don't make it zooming really weirdly. But you get the idea. That's the sprite sheet that I want to use, but I somehow need to turn this into voxels, and for that I need the ability to map these to voxels. Oh, never mind. Okay, let's work on that. So I can get rid of these things that are only here for testing. This is fine, I guess. Okay. We need a little bit of state for some of the controls. I need the state for displaying a texture. So it needs scroll position, since I want it to be scrollable, and basically here we're gonna do texture display. I guess I don't need, I just need the app. Okay, to be able to do the texture display, I need, okay, let's get rid of more debug stuff. This is fine. Alright. So I need to be able to load a texture. Which we're gonna do by loading it. The platform layer, where are the platform stuff? Platform services. Platform. Game declarations, there it is. Okay. We can load the texture. And then I need a way to get the image data. Didn't I write that? Oh, I have a texture map. That's where I do that. Okay, so we go ahead and open an open file name dialog, which takes a filter. Don't care. Can I leave this as null? Let's try it out. Initial directory. File name buffer, and okay. Okay, if this returns true, it means we selected the file. We then can load the texture. I need a way to delete the previous texture since I don't need it anymore. Hi Festec, how are you storing textures in STDMap? No, I'm just storing them in an array, contiguous array. I don't have an implementation of map currently, and texture map access is so I don't do that so infrequently that I won't be implementing a map just to store them more efficiently. Right. I need one of these so I can delete the previously loaded texture. So this needs to be implemented. Okay, load texture takes a string view, so we pass in the file name. Oh, this returns an integer. Okay, so I need to do this differently. Right. So this is the file name length. We load the texture into the editor texture right here. And then we are gonna display that for now. So we take a render. Region. I called it region, right? Yes. This will give me allocate me a rect from the GUI window, which I can then use to render to. It takes a width and a height. So I need to know the texture width and texture height. Then I can set the texture and render the texture. Using that rectangle that we know that we placed on the GUI. Yeah. This isn't returning anything. This is gonna be a control in the future. Currently it's just rendering. That's why it's gonna return whether we clicked on it. Okay. And we need this delete texture thing, which I'm gonna ignore for now. Okay, so this is not allowed to be null. Is it really not allowed to be null? Okay, where is the get open file name call? Or I guess the structure is the important part. So can I set the filter to null? Okay, so it can be. I just have a bug here. Like this. Okay, it's working. And if I do this now, we loaded the texture, but we're not displaying anything. I am executing this path, right? Yeah. So this should be working. Oh, I didn't initialize texture width and height, that's why. Okay, let's do that. So for that I need get texture texture don't I have a function for that? How do I query stuff from here? Texture map. Texture map. Pretty sure I'm already using it somewhere. Huh. Okay, when I'm loading the textures right here, oh, I'm just doing it manually. Alright, that's fine. Maybe I should have functions for those queries so that I can change the implementation later. Let's do it right here. Okay, the texture map. Oh no, there it is. Get texture info. I already have it. I just didn't look at the right place. Okay. Yeah, I need to call this function. This returns a pointer, and then I get the width and the height. Why is this so big? Oh, there it is now. Okay. So we're loading the texture. Instead of getting a region here, I want to create something that's scrollable. So scrollable. So we change this. So it needs scroll position, which we have right here. Okay, what was the next thing? Scroll position, scroll domain is the size of the texture. Which I'm gonna scale. And then the width and height. So the display should be 400 by 400, but we can scale the texture. And if we scale more than these sizes, it's gonna scale. It's gonna show scroll bars. That's what this thing is doing. And I shouldn't be getting the renderer like this. I should be getting the renderer the GUI is using. Then we are gonna clip on this rect. Okay, let's see what this is doing now. There's the scrollable region. Currently, we didn't load any texture, that's why we are rendering just white. Since 0 is the plain white texture ID. And if you load our texture, it's now stretched instead of zoomed. So I should have rendered this instead. Why is this null now? Oh, we need to translate this. So that it's inside the scrollable region. We were just clipping it completely since I was rendering it at the top left screen position instead of inside the right position. And there it is now. So next thing is we are gonna introduce the scale. Where's the header? So I need a scale here. Okay, after this button, we go ahead and do a slider for the scale. It goes from 1 to 10, I guess. What's the definition for slider? Oh, it needs a name. Then a pointer to the scale and a min and max. Okay, that's fine. And then up here, we scale the texture. But I'm not using the scroll position, so this isn't doing anything yet. But the scaling works. So when translating, we also need to take the scroll position into account, which is stored in this value. Okay, but we're scrolling in the wrong direction. So this needs to be a minus. And there it is. Okay, this is scrolling a little bit too much, so I have a bug in my scrolling code. It should only scroll the remaining size, and it should set the scroll position back to 0 if the scroll bars aren't needed anymore. So I need to change the scroll bar code for that. Or no, ng scrollable. Okay, else. So if a scroll bar isn't active, we need to set the scroll position back to 0. The same for the Y. So if I scale, scroll, then scale back, yeah. And then I need to fix that we can scroll the whole texture to the left. Which is a problem with calculation here, I think. I can still scroll past it, but no, the scroll bar isn't showing up. The scroll domain itself should be shorter. It should be okay. Now the scroll bar is bugged, but the scroll domain itself is correct. So when I'm calculating the pedal width, which is the black bar of the scroll bar, I guess I need to do this calculation. This is the domain width and the width of the scroll bar itself, and I need to add them together. Wait, page size. Alright, there it is. I fixed it for one, but not for the other. So we need to do this here. I guess I shouldn't be doing this myself. The scroll bar should do it instead. So we do this then. Or we do instead. Okay, this is fine now. So this is the texture atlas. I want to click on a rectangle and then refine the texture coordinates for that, and then populate it texture map for the voxel engine to use. So next up, we want to be able to define regions on the texture. I don't need this anymore. So I need to be able to store texture regions in an array. This should this can I leave this as an array? I'm gonna use texture picture image processing. There is this algorithm which finds rects of it finds pixel clusters in an image where the max distance from one pixel to the next is defined by this value named border. Okay, it accepts an allocator, so that's not useful to me then. So I'm gonna change this slightly. So this is the main algorithm now, and then this version just calls into the other one. Yeah, like that. And this manipulates an array in place. Which means then I can go here. This is fine, I just need to allocate the region. Let's say we can detect up to 100 regions on a texture. Then here let's see, texture map. We are storing the image pixels of the image in this file. What's the image? Find rects. We pass in the regions, the image data, which is called just image. The region is the whole image, and we tolerate 0 pixels, border of 0 pixels. So what it's supposed to do is it's gonna find all the clusters of pixels, which in this case correspond to each of these sprite sheet entries. But this image region thing, it's not allowed to be 0 currently. So if region width so region right, so passing in a zeroed out region will just expand it to the whole image. And then here we can iterate over all the regions. I can't do it in here actually. Since I need to change the texture. Alright, now we can iterate over the texture regions. Let's do opaque black. Okay, translate this same as this one, so let's call this the origin then. There's a slight problem, or maybe not. We also need to scale these. Okay, no, this should be fine. Except there is no version of the multiply operator that accepts 2 different types. Where is it? Operator multiply. Yeah, I defined it as taking the same types here, which isn't useful. I just didn't think of a better thing, better interface. What it should be doing is it should be taking two different types as inputs and return the common type. So it looks a little bit ridiculous now. I don't think I need to do I don't think I need to do conversion here. This should be working as it is. And otherwise it's gonna return, if I supply it with two incompatible types, it's gonna return an error message, which is fine. Okay, do the same thing for the other way around. So this color becomes S and this becomes C as a return type. So this allows me to pass in an integer-based rect and a float scalar, and the resulting rect will be float-based, which translate once, although translate is also a templated function. Okay, the left of dot image. This is a pointer. Okay, this is compiling. And there's an error here. We are detecting more regions than we have. So I didn't do bounds checking here. Y equals height break. So setting this makes it so that we break out of the outer loop, and this breaks out of the inner loop, which means we exit the loop. So 100. Let's just see what the output is. Right, the regions it's finding. Wait, huh? It's just finding single pixels as regions, and then after 100 pixels it's filled. So the algorithm isn't doing what I thought it would do, I think. So let's make it so we're using a different color for each quad we're outputting. Plus so I don't have an index. Let's see, colors. Let's have 3 different colors. Love this indent level on the right side, by the way. What indent level? Okay, yeah, all the texture regions were individual pixels, as I suspected. Okay, the algorithm isn't working, it seems. Or maybe if I allow a border of 1. It's still single pixels. So I made a mistake here with this algorithm. 6 tabs. Okay, let's close a couple of tabs. There, 3 tabs. Okay, what this algorithm is doing is here I'm just looping over the image until we find a pixel that has an alpha value of non-zero. This is the alpha component of the pixel. And if you find a pixel that has an alpha value of non-zero, we check whether we already added it to a region. No, by tabs I meant they always were saying me to not use 2 or 3 indent levels. It is really better to use lambdas break continue. Oh, you mean for nested for loops? Well, it depends. If you need to be able to break out of multiple nested for loops, then lambdas are actually very useful, since you can do a return. But well, I did write this loop before, and I didn't need to break out of the loops previously. I just added the breaking out of the thing. So I guess I could put it into a lambda. Which also, the cool thing about the lambda is it's self-commentating, self-describing what the algorithm is doing, since you're giving it a name. Find first pixel. Actually, can you do unnamed lambdas? I never tried this. But let's try this one before I'm giving it a name. And then call it immediately. Does this work? So it should take everything by reference. And then here I can just do return. Yeah, it does work. It compiles. Interesting. Alright, now we can return, basically. Just let me check that I didn't introduce a new bug by doing that. So yeah, it's still single pixels there. Okay, once we find the first pixel that is set, and we didn't add the pixel into a different region yet, we then go into this other algorithm, which is supposed to expand that. So let's say we have an image here. These are all individual pixels, right? We find the first pixel that is visible, and then we are supposed to expand this region in all directions greedily until we can't expand anymore. So that is what this algorithm is doing, or it's supposed to, but it seems to not work. Okay, quick glance here makes me think it should work. I don't see a problem with it on a first glance. Border is set to 1. Okay, so what am I passing in there? I'm passing. So here we are trying to expand to the right. Width is the width of the image. And then it takes the top and bottom of the current region, which is this part. And then it's looping over all the pixels vertically. Okay, let's make a new picture. So let's say our current region looks like this, and we are trying to expand to the right. So we need to check all the pixels of the current region vertically, and if any of these pixels are set, it means we can expand this region to also include those pixels. So that's the idea behind this. This 4 just means each pixel has 4 components. Stride. Am I calculating the stride correctly? Yes. So this first So this is the column stride, this is the row stride. When I'm going to the right, I need to go 4 to the right, advance by 4, that's correct. And then when checking vertically for the set pixels, I need to advance by the stride. That's also correct. Okay. I don't see a problem here. So let's try to expand to the right only. What happens? Still the same pixels. And let's make it so that we can only find a single region. So I can check what that's one. So it's a single pixel. Yeah, it can't expand to the right at the beginning. So let's allow it to expand to the bottom. No, it doesn't do anything, so we can now break and see what the algorithm is doing. Since it should be working. It should be able to expand to the bottom. Okay. So the left and right of the region is 7 and 8, which means we are at the pixel 7, and here's 8. We found a single pixel, and we are trying to go down within this horizontal span. What is and? What did I pass in there? And is the third argument the height of the image in total. Okay. So we are going one down each iteration, and then we check the horizontal pixels, which is just a single pixel. Okay, this should have been true. Hi, Imageables. Why current, let's see, column. What is column 3? It is 0. Why it is 0? The column stride. Oh. I mixed up the strides. That's why. I was checking the pixel to the right instead of the pixel below. So I think I just have a switcheroo here. Okay, let's try this again. Uh, what's that texture atlas? Um, okay, texture atlas is there are multiple ways to define texture atlas. I'm not doing a texture manager kind of texture atlas, so I'm not packing all textures into a big tech atlas. Currently, all textures are single IDs on the GPU currently, but what the texture atlas I'm working currently is I want to pack a sprite sheet, sprites into a single texture. So I have, if I give it multiple files, it should be packing them like how it is on the screen currently. So multiple images land on a single texture, so I don't have to have a lot of context switches. Okay, it fails to expand still. So uncomment this again and then step through the code. Okay, I should. Oh no, no, no. That's a mistake here. There wasn't a switcheroo. This loop here is supposed to. So if I'm currently at this pixel, I should be moving one down and then check this whole row of pixels to see if any of these are set. This is why this loop here is moving horizontally, so column straight of 4 was correct. But I think the problem is before that. So I'm supposed to go one down already. Yeah, I think this here is a problem. Yeah, I'm not. Or am I? Okay, so there is the problem here that I am not advancing the pixels to the start of the region. I'm just reading from the top left of the texture every time. So this needs to be like this. Columns right. No, it should be the rows right. I expanded one to the right. Okay, that's not correct. Still not expanding to the bottom. So what's the current position of the column? Pixels. No, wait. Column minus pixels. So that's the index is 800. 800 divided by 400. Wait, what's the height? $76. 800. Wait, it should be modulo. Both of these values are wrong. Oh, I should be dividing by the width. Modulo is 0. So I'm 8 already from the top. That's not correct. Okay, let me make a sample image that I can check against. So this is just a white rectangle. Oh, I already have something I can test against. Okay. So load a different texture and test that one. Well, now we're finding the whole region. That's done. Why is this pixel black? Oh, it's black here also. Okay. Alright, let's make that top left pixel invisible. Paint can't do alpha channels, so I need to open this program. Save. So now the algorithm should be failing. Okay, it just ignored the left pixel, left column. Okay, so expanding to the right seems to be working. Yeah, this is working. So it finds the first set pixel, which is this one, and then it expands to the right as much as he can, and then he expands to the bottom, which is also working. So, but I think it's only working incidentally because of I'm not doing the start correctly. Wait, no. So let's change the start position here. Okay, this seems to be working. Expanding to the right is working. Now expanding to the bottom. It's also working. It's the correct region. And now if expanding to the left is working, it should be selecting the whole texture. And it is. Okay, so why is this failing? Okay, let's make this more complicated. It should now select the whole texture except the first row of pixels, since that's completely invisible. Okay, there's the bug. We reproduced it and now we need to fix it. Before we do that, I'm gonna take a short break. I'll see you in a few minutes. Alright, I'm back. I think I know what the problem now is. Right here. So this is the beginning of the image, the top left corner. It's the top left corner. And then the start position is from where I'm supposed to start searching. So if I already found this pixel here, I'm supposed to start searching to the right of that pixel. So I'm advancing from the top left corner of the image to the right by the amount I set. So the top left corner, I'm going to the right that much, and then I end up at this pixel here instead of at the pixel below it. So I need the Y position of where I am currently also, which is the min value. Since that is the top of the region I'm currently at. So if this is my region that I already detected, the top is this amount. So I need to do column stride. This calculation. And I think we fixed it. As I said, we are now selecting the whole texture except the first row. That was what I expected, and we are doing that. If I load this now, we are selecting the whole texture instead of a single dude, a single frame, which is because I allowed a border of 1, or the search is allowed to skip over one unset pixel. So if it's searching to the right, if only one pixel is unset between two set pixels, it can combine those regions. So if I set this to 0, hopefully it's gonna select a single frame now. Alright, we're selecting now a single frame. Okay, is that pixel being color coded? And that lambda is kinda huge for lambda 2. This one? Well, I don't think there are any size restrictions on lambdas. They can be as big as you want them to be. And the only reason this is a lambda is just because this is the only place ever that it's being called right here. This lambda here is just here so I can break out of both loops at once. And other than that, these are algorithms. They just loop over data a lot. So I think refactoring this into smaller chunks doesn't make any sense. Okay, now if I make it so that we can detect more regions, we should be able to detect all the frames. Except what went wrong? Did I change something? Oh, you're just selecting one single frame now. Why did I select the whole picture? Wait, why? What? There should be 2 regions now, but instead only the first region became bigger. And there is no second region. Where's the second region? I'm pretty sure we are only rendering one. Okay, let's see. What is the second region? So we do this. There are 2 regions detected, but only one region outputted. So it actually is only just one region. Why is that one region getting bigger depending on whether the remaining size is 1 or 2? Let me disable this for a second. Okay, now there are two regions. One is this red one, or the second region here is overlapping with the first region, and the second loop was removing overlapping regions. So the red one here, which is below the green one, is being removed. So the problem is the second region here, which is too big for some reason. Okay, somehow so the second pixel I'm finding should be this one here, to the top left, top of the second frame. Let's make sure that my assumption is correct. So this is the first one, the second one is at 22.0. 22.0, it's this pixel, yes. So when expanding this pixel here, it somehow manages to find this whole region. But it shouldn't be able to jump from this pixel here to this one. So let's go back to our test case. So if I have a pixel here, so the algorithm should be finding two regions here, since it can't jump over this gap, hopefully. It's wait, maybe I should be using white here so I can see whether a region is detected. Okay, it does find two different regions. Okay, so why is the algorithm failing? Let's use this as my test sprite. Alright, it somehow manages to jump to the left image. I would like to know at which point. Maybe some of these aren't fully invisible? No? How is it managing to jump over this gap? So if I increase the gap here, let's make sure that that is the problem. If I increase the gap, okay, expanding to the left is broken. So if I comment this out, they shouldn't be overlapping anymore. Yes. This is looking correct. So then expanding to the left. What's the problem here? Okay. So my start is left. The left side of the pixel. The offset is -1. Since I want to go one to the left, I want to start checking one left to the current pixel. And then I multiply that by the row stride, which is 4, which is correct. This is the stride for moving left and right on the image, plus the top of the rectangle times the vertical stride, which is also correct. And then I continue going to the left since step is -1 until as long as I isn't -1, which is if that were true, we went one pass to the left edge there on the image. That seems correct to me. But that is the function that is failing. When we're expanding to the left, we're expanding always too much. Yeah. So let's just debug expanding to the left. Okay, for the first row, it fails to expand, which is correct. Let's allow expanding to the bottom. And now it fails. Okay, what happens if I remove this one? Interesting that the first region doesn't have the same problem as the second region. The first region terminates correctly, almost. It's 1 pixel too far to the left, but the second region goes to the left too much. Oh, that's why. I'm moving to the right instead of to the left, since I'm always adding. This should be time step. So when moving left, I want to subtract. I want to go in negative direction. That's why moving to the right and bottom was working correctly, but then moving to the left, I want to subtract. And similarly here. No, this is always correct. This can stay positive since I'm always looping from the smaller value to the bigger one. And then moving to the left, I'm moving from bigger addresses to lower addresses. That's why it needs to be negative here. Alright. And now the left expansion is correct. So if I uncomment everything, you're only detecting one single cell here and here. Okay, now it's working. We are detecting 2 different frames. If I increase the number of cells we can detect, we should be detecting all of the frames. Okay, we failed to detect this guy, and these got combined for some reason. let's remove this for now. Okay, that loop at the end seems to be bugged, since it was combining these two. Oh wait, I think I have a bug here with the colors. I actually am detecting all of them. Yeah, I am. And now it's also clear why these 4 cells here get combined into a big single cell, and that's because these two regions are overlapping here, so they get combined, and once they get combined, they are overlapping with these two cells, so these two cells are also merged into one single big cell. So I guess I will just not do merging of cells. Maybe put that in, have a boolean here that merges. So we don't want to merge overlapping cells. Now we can detect these things. Next, I want the ability to click on them, and then adjust the texture coordinates if I want to, and then save them as mappings to be used by the Voxel engine. Actually, this is wrong. I should be getting the inputs that the GUI is using. Okay, I have a bunch of cells, which I don't need to render. This is all just rendering cells. You can get rid of this whole block. Alright. Let's loop over all the texture regions that we detected and then check whether the mouse is over any of them. So scaled is just entry times editor texture scale. This is the scaled rect. And then if the mouse cursor is inside, we render the selection rect. Yeah, it needs to be scaled and translated by the origin. And if the mouse cursor is inside, we also, before we do this, we need to make sure that the mouse cursor is inside the control itself. Since otherwise we can select regions that are clipped by the clipping rect. Yeah. Do I have a handle? This just makes sure that we're hovering the current control and there isn't a dialog in the way. The detection of the mouse cursor being inside the cell is correct, but the render position is wrong. Yeah, it's offset in a weird way. Oh, I'm translating twice. This is already translated. Alright, there it is. So now if I click on one of them, I should be selecting it and then be able to adjust texture coordinates. And then, okay, let me think. So we're gonna select one, which means I need to store that we're selected. So at the beginning, this should be -1, since we haven't selected anything yet. I need the index of this thing. Do I have the index of? Let's see. What? Oh. Texture display. And it seems I do have an index of. That is good to know. So I want this to work differently. So if there isn't anything selected, we then go into this loop. And then we select the thing. And then if there is something selected, we display something where we can manipulate the selected region. This operation, I basically need to do this every time I'm talking about rects. So we're scaling by the scale and then translating by the origin. So this should be called transformed, but it's fine. Alright, I need to go quickly to the bathroom and then we will implement this. Gonna be right back. Okay, I'm back. Um, where was I? So we can select frames, and I want to change the behavior when we click on one of them. Okay, which is right here. Right, and then here, same thing. Scaled. I think this is not gonna work because I can't clip line segments yet. But let's try it out. What does this need again? Rectangle, value domain, which is both of them are just the rect. No, the value domain is the texture rect. Yes. So now if I click on one of them, it does display the rectangle, but it's hard to see. There it is, because it's black. Let's change the color to white. Not working as expected. Oh wait, this only needs to be scaled. Because this function already, it takes coordinates that are relative to the rectangle, so I don't need to translate myself. So let's do the easy case where it's not scaled. Interesting. Why is this working inversely? Oh, this because this is scaled. Right, still something weird going on here. This rectangle is way too big. So I need to use debug output here. Right. So debug output. Right, these reside in two different states, so that's why they're not working together nicely. That's fine. Now I can do debug print line and then print the rectangle to then see huh? Why didn't this work? Oh, that's why. This does the printing and this displays it on the screen and this does the printing, and they were the other way around. That's why I didn't see them. So 001424 is correct. So as I'm scaling, these values don't change. That means they're doing the correct thing, but why is this rectangle on the screen this weirdly? So me dragging this thing around does modify this correctly. Oh, what rect is doing is it's scaling this value domain on this whole rect. So the value domain is wrong. So that's why it's looking as if it's scaled. Imagine this texture stretched like this, and then so the value domain of the texture is stretched to this rectangle, and then this rectangle, the thing here makes sense. So why doesn't it accept my color change here? Oh, because I'm setting the color here. Okay, now it's white. So what to do about that stretching issue? So the rectangle should be the scaled texture rect. Right, now it makes sense. But we also need to translate this. Okay, this is working as expected, except you're not doing clipping correctly. Yes, this is what I wanted out of this. Except why is this resetting? Oh wait, there is a bug there. There are more than one output. 1, 2, 3 outputs. What is this 90? Oh, okay. Never mind. Okay, why is this resetting? Oh, because of this. No? Oh, should be doing this. I was manipulating a temporary value instead of the thing I'm storing. That's why it was resetting once I stopped dragging. Okay, now it's not resetting. So next thing, I want to be able to snap this into I want to be able to snap this to pixel boundaries, snap to pixels, since currently this is way too freeform. Right, and then here, so this method will return true if the value changed of the selected region. Then we need to snap these to pixels, which is just the florid. Right. This is behaving exactly how I wanted it to. So it's snapping to pixels. But while I'm moving, it's still fluid. But if I release the mouse button, it snaps to the nearest pixel. And if I disable snapping to pixels, it's still freeform then. But I should be doing this regardless of this returning true. That's because I wanted to snap to pixels immediately as I press this checkbox. So now it's freeform, and it should be snapping to pixels as soon as I click here, and it does. Okay, now I want to be able to deselect, which I'm gonna do by doing something similar to this here. Wait, this doesn't need to be in here. Let's make it here. And is key pressed inputs. If the right mouse button is pressed, we deselect, which is just we set the selected index back to -1. So if we accidentally selected the wrong frame, we can go back and select a different one. Alright. Should fix this, but then again, this is just an editor that's not user facing, so I guess I don't need to waste time with that. Okay. Takes a name, left pointer. That's it, okay. Left, top, right, and bottom. Oops, I picked the wrong texture there. Okay, once I select one, this enables this drop down group, and I can change the values in here too using edit boxes. Why is this flashing this fast? Why is this flashing so fast? DT. Am I passing the wrong delta time here? No. Well, that's weird. But I guess it's fine. Okay, next thing is next thing. So the end result is supposed to be, I want to populate one of these voxel grid texture maps. It has 6 entries of texture coordinates. So a voxel has 6 faces, since it's just a cube in space. It has 6 faces, so each of these faces can have their own texture coordinates. And that's what I'm basically doing. I'm specifying a mapping for a whole voxel-based mesh. So these 2D sprites here are supposed to be mapped to a model like here, in here. So each of these voxels have texture coordinates, and even though it looks kind of 2D-ish, these are 3D models, which I am manipulating using this voxel editor. And this voxel editor currently can't do texture mapping. This mapping here is hard-coded, and that's what this editor is supposed to do. It's supposed to define the texture mappings that this editor is gonna use, and then lastly the game itself. Yeah, so to do what was it called? Texture map, voxel grid texture map. Right. So I guess I need a list box of which face I am currently manipulating of the voxel. Then I'm gonna specify which sprite that face is gonna use. So I guess I need a list box here that lists the 6 possible faces: left, top, right, and bottom, front, and back. Then I select the face, I select the texture, I manipulate the texture coordinates if I need to. Do that for all 6 faces and then save the texture mapping to file, and then I can use the texture mapping in the voxel editor. Right. So that's what we're gonna do tomorrow. I'm finished for today. Thanks for watching. Make sure to follow me on YouTube, Twitch, and Twitter for notifications. Don't forget that this project is open source now. You can find the links in the description below. And thanks for watching. See you tomorrow.